So now let's see CBSE 10th Max Chapter 8, that is Trigonometry, third exercise 8.3. We have already completed the first and second sums and now we are moving on to the third sum. Okay. What is given? Tan 2a is equal to cot a minus 18 degree. So how can we write tan theta? We can write it as cot 90 minus theta, right? Cot 90 minus theta. What is theta here? 2a is equal to cot a minus 18 degree. So both sides we have cot, okay. So we can equate this thetas. So 90 minus 2a is equal to a minus 18. 90 plus 18 is equal to, this a is going that side. So a plus 2a will become 3a. What is 90 plus 18? It's 108, which is equal to 3a. So a is equal to 108 by 3. The value will be around, the value will be 36 degree. 108 by 3 is 36. So let's go to the next question. So now let's move on to the next question. That is the fourth question. What is given here in the question? It's given that if tan A is equal to cot B, prove A plus B is equal to 90 degree. So tan A is equal to cot B. Okay. How can we write tan theta? We can write it as cot 90 minus theta, right? So cot 90 minus, what is the theta here? It's A is equal to cot B. Both sides we are having the cot theta, so we can equate it. Okay, we can equate the thetas. That is 90 minus A is equal to B, which implies this A will be going that side. We'll get 90 degree is equal to B plus A. That is what they have given the question also. A plus B is equal to 90 degree. So we have proved it. These are very, very simple sums and very easy for us to do. So now let's go to the next question. That is the fifth question. If secant 4a is equal to cosecant a minus 20 degree, where 4a is an acute angle, find A. What is given here? Secant 4a is equal to cosecant a minus 20 degree. Again, we are changing it. Secant theta can be written as cosecant 90 minus theta. So cosecant 90 minus theta. What is theta? 4a is equal to cosecant a minus 20 degree. Both sides we have cosecant theta, so we can equate the thetas, which implies 90 degree minus 4a is equal to a minus 20 degree. So bringing that 20 here, we'll get 90 degree plus 20 degree is equal to, and bringing this 4a there, we'll get a plus 4a, which implies 110 is equal to 5a, and a will be equal to 110 by 5, which is equal to 52 degrees. Okay, the value of A is 52 degrees. Now moving on to the sixth sum, what is given that? It's given that if A, B and C are interior angles of a triangle, show that sine B plus C by 2 is equal to cos A by 2. So in the LHS, what is there? It's given that LHS is equal to sine B plus C by 2, right? We have given that A, B and C are angles of a triangle. So we know that sum of the angles of a triangle is equal to, which implies A plus B plus C is equal to 180. So B plus C will be equal to 180 minus A. So in this LHS, for B plus C, we can substitute 180 minus A, okay? So LHS is equal to sine 180 minus A divided by, so this can be written as sine 180 by 2 minus A by 2, which is equal to sine 90 minus A by 2. Okay. Now come to the RHS. In RHS, what is given? It's given cos A by 2, right? How can we write cos theta? We can write cos theta as sine 90 minus theta, right? Sine 90 minus A by 2. Okay, the theta here is a by 2. So we have written it as 90 minus a by 2. So the LHS also we have got the same thing, and RHS also we have got the same thing, which means LHS is equal to RHS. So we have proved what is given in the question. Now let's move to the next sum. That is the seventh sum. X plus 0 degree and 45 degree. So they have given some angle of 67 degree and 75 degree. They have asked us that we have to bring it between 0 degree and 45 degree. So how can we do this? Sine 67 degree plus cos 75 degree. How can we write sine? We can write it as cos 90 minus theta, right? 90 minus 67 degree plus, or how can we write cos? We can write it as sine 90 minus 75. Now, so 90 minus 67 is 23. It is somewhere between 0 and 45, right? So we have done like this 23 degree plus sine. What is 90 minus 75? It's 15 degree. So we have brought two different angles, that is 23 degree and 15 degree, which lies between 0 degree and 45 degree. So this is the answer for this sum. So we have completed all the sums of exercise 8.3. If you have any other sum request, you can let me know in the comments. So I'll be solving that sum for you first. Thank you.